Alright, so this should be the last section for the chapter. Right now it is, and if there happens to be another section, I'll mention it in class. They're talking about adding some content to Math 151, and if they do, the content, some of the content that they're thinking of adding, I'd probably put into a section 2.5, but I'll mention that in class if there is another section at some point in the future. Anyways, this is our first word problem section. If you took intermediate algebra at GCC, then the word problems that you're about to see could be an absolute duplicate of what you saw in intermediate algebra. A lot of this section I just cut and pasted from my intermediate algebra class material, and then I added a few problems. But a lot of this could be review. If it's not, it's okay if it's not review for you. Well, I'll treat it like it's new. But hopefully it's not completely new. Before we get deep into the section and getting into the word problems, there's some terminology or definitions that we need to understand or know the meaning of to be able to do the problems. When I give a test over any material, I never ask you for a definition, but you need to understand certain words, and that's what I'm going to spend the first few minutes going over. So in this section, there are kind of three big words that we're going to concern ourselves with. And on this sheet, the first of the three words is directly. And that word directly in this section will be sandwiched between some words. So in this section and some of the word problems, I might run across the word varies directly as, or I might run across the words is directly proportional. The key thing that those two little fragments or those series of words have in common is they have the word directly, and anytime I see the word directly in this section, those words I'm going to replace with equals some number times. Whether it's the three words varies directly as or is directly proportional to. So immediately I think equals some number times. So when I think directly, I think multiplication. There's more that I probably could say, but in the context of just getting started, I think it's probably important just to connect directly with multiplication, and then we'll move on to the next page, which is going to have the other two words that are going to be important in this section. The next word that's going to be important is the word inversely, and in this section usually the key words are preceded and followed by words. In this section we might see the word varies inversely as, and when I see the word inversely in this section in a problem, I don't think multiply, I think divide. And for us, instead of using a division sign for divide, I'm going to form a fraction for divide. So when I think inversely, I think fraction in some case. And I have more words down here. When I see the words varies inversely as, I'm going to replace those with equals some number divided by. And in a bit, we'll talk about the sum number that I get to use in every problem. And I'll just kind of move on and save these words for later, but I can read them, but it's kind of out of place right now to talk about. We normally create a fraction with a k in the numerator. That's a little premature. The last word that's going to be important in this section is jointly. And again, any of the key words that we might be presented with in this chapter are usually sandwiched between words. And in this section, we might see the words varies jointly as. And if I see the words varies jointly as, I'm going to think equals some number times. So just like directly, the word jointly, the algebraic operation that I'm going to think about when I see jointly is also multiplication. As we get into the section, there are two words that mean multiplication. There's one word that means division. The reason there's separate words, two separate words that represent multiplication, has to do with the number of terms that are being multiplied. And we'll get to that as we get into the section. But for now, when you see the word varies inversely as, if you just either physically change it or in your mind think equals some number divided by. If you see the word varies jointly as, if in your head or physically you've transformed the problem to say equals some number times. And if you see the words varies directly as or is directly proportional, if you change those words to equal some number times, it'll make the section easier to follow. So again, the important things is to remember inversely is divide, we use a fraction, jointly and directly is multiplication. So the first 8 problems in this section completely just want us to get used to these words. Each of the first 8 problems gives me a sentence, and that's not even a question, and some of my sentences have periods after them, some of them don't have periods after them. That's just because I'm not so great at English. But the instructions, again, are probably the important part. It says, write a variation model. Use k as the constant of variation. What this instruction means to somebody that reads mathematics is to transform or to create an algebraic equation that models the sentence. So that's what the first sentence means. You create an algebraic equation that models the problem or the sentence. And in these problems, we're going to introduce a letter that's not already given in the problem, and we call that letter the constant of variation. And the second sentence says use the letter K for the additional letter or the new letter that needs to be added to the problem. So for each of these problems, we're going to take the sentence, we're going to create an equation that doesn't have words, that has the same meaning as the sentence. And for each of the problems, I'm going to look for the keywords, or keyword, directly as the keyword. But again, and any keyword is usually sandwiched between words. And when I do my problems, I'm either going to physically rewrite the problem without the keywords, with the words that are equivalent to keywords, and then I'm going to create an equation that models the problem. So if I was doing problem 1, I read it as W varies directly as the square of x. The words varies directly can be replaced with equals some number times. So your problem 1, I can rewrite as W, and then varies directly as can be changed to equals some number times. Equals. So that's just doing this the switching out of varies directly as to what it can be transformed to that's maybe more understandable, and then the square of x. So this version of problem 1 has the same meaning as the initial version of problem 1, but maybe it's more understandable. And now I can start to understand my the problem better. So what I'm going to do is take this sentence, transform it into an equation that doesn't have any words, and very specifically I'm going to make the symbols in the problem and the words in the problem in the symbols. W is going to stay W, equals is going to turn into an equal sign, and it's the sum number. That's the new letter that needs to be included in the problem, and I don't want to use an X, because this problem already has an X. And some of the problems will have X's already, some of them won't have X's already, but none of the problems will have K, and that's why this instruction, use K as the constant of variation, use K as the new letter that needs to be added into the problem. So for the sum number, I'm going to use the letter K. And then for the word times, I could put a times sign in for the word times. But if after that letter K, I just put another letter, I don't need to have a times sign. Two letters written next to each other, the operation will be implied by times. So I'm not going to put anything in for the times. And then the square of x is the last thing that I'm going to replace with a symbol. And the square of x is an x with an exponent of 2. This would be the answer for problem 1. There isn't anything more to do because there aren't any numbers in the problem. So I'm just creating an equation that has the same meaning as the sentence that's given to me. In this section, we have to understand some words. And let me just scribble down here at the bottom. The words that we might see that we're going to have to translate to letters might be something like the square of x that I just saw. We might see something like the square root of x, which we're about to see. Later on, real quickly, we're probably going to see something like the cube of x, and we might see something like the cube root of x. So these are the sorts of words that might appear in the problems in this section. And if I see the word root, then the x needs to be under a radical symbol when I transform those words into symbols. If I don't see the word root, then the word is going to turn into an exponent. For the square of x, I just did it. Square kind of implies 2 to me, and that's just going to be an x with an exponent of 2. Whereas square root is going to be a radical symbol with an index of 2. So when I see root, I think radical symbol. The x is going to go under the radical symbol, and this word is going to become the index. So the index is going to be 2, and that would be something that would mean the square root of x. Of course, if you wrote a square root symbol without the 2's implied. So square root of x, I'd probably just turn it into a square root symbol. For cube of x, because I don't see the word root, I'm going to write an x with an exponent, and the exponent that relates to the word cube is an exponent of 3. And then for a cube root of x, immediately when I see root, I think radical symbol with the x under the radical. And for a cube root, 3 is the key number, 3 is going to be the index. So the words square of x, cube of x without roots give me exponents when I'm translating the words into symbols. Square root of x and cube root of x give me radical symbols with the x under the radical. All right, I'm going to do number 2 and then eventually get off this page. So if I'm doing number 2, I think of this problem as A, and then these words in my head I think of equals some number times. And then the square root of b. So just like I did the last problem, I'll just go through, read the problem from left to right, leave the letters as letters, change some of the words into symbols. The first letter I see is the letter A. I'm going to write that to the left of an equal sign. And then the next word I see is the word equals. And the word equals, I'm going to change to an equal sign. The next two words turn into a symbol. The sum number is going to turn into the letter K. For each problem in this section, when I rewrite the problem into words that I'm more comfortable with, the sum number is going to turn to the letter K. And then the times could turn into a time sign, but usually I'm not going to need the time sign because I'm just going to write two letters next to each other to indicate the times. And then the last thing I'm going to have after that K is something that represents the square root of B. I'm not going to put an X in this problem because the letter is a B. And after the K, I'm going to put a square root symbol, and then the B is going to go under that symbol. This is going to be the answer to number 2. All right, I'm going to flip over and do problem 4. And while I do 4, hopefully you can do 3. Both problems 3 and problem 4 have the word inversely in it. And with inversely, I think fraction. And a little more specifically, usually when I see the word inversely, I normally create a fraction with a K in the numerator. So I'll do that here in a second. First thing I'm going to do is rewrite the problem with words that I understand better. So I'm going to replace the words varies inversely as with equals sum number divided by. So this problem, which was given with really precise mathematical words, can be changed into equally precise words but more easily understandable words. So that's how I would reinvent problem 4 to make it so I can create an equation with a K. So I just took the words varies inversely as, traded them out to equal sum number divided by. And now I'm going to form my equation. The first letter I see in my reimagined problem is Z. I'm going to write it first. Then I see the word equals, or equals I guess, probably should say equals. And then that equals is going to turn into an equal sign. And then for the sum number, I always use the letter K. Because this is inversely, I'm going to create a fraction with a K in the numerator. So the divided by tells me I can use a fraction or a division sign. For inversely, I usually form a fraction for the sum number divided by. That's kind of what I've shown now. This is sum number divided by. And what it's divided by is the square of y. Because I don't see the word root after the word square, the y is going to get an exponent of 2 as opposed to being under a radical symbol. So the difference between square and then root, square root, is with square you get an exponent, with square root you get a radical symbol. For my problem, the square of y is going to go in the denominator of that fraction, and I'll get my answer for problem 4 as z equals to k over y squared. Alright, so your problem 3 should work just the same way. Move on to problem 5 and problem 6, which are a little bit trickier problems, because they have 2 of the words, and one of the words is written in a way that I didn't even mention it could be written. But let me jump into number 6 and just try to break it apart for you. So number 6, the first thing I notice is it has the words directly in it, which is fine. I mentioned that already. But it also has the word inversely proportional. And I didn't quite mention the word inversely proportional. I used the word varies inversely. on this sheet, I probably should have said inversely proportional, those words. Can also be replaced with the words equals some number divided by. I'm going to need that for this problem. But the key word is inversely, I think divide, directly, I think multiply, and there's multiple ways you can incorporate the words directly and inversely in a sentence, and I just didn't know that I guess I should have known. I wrote this stuff. I didn't realize I used inversely proportional, kind of interchangeable with varies inversely as. So as I go to do problem 6, the problem I can think of as W, and then these words is going to be equals some number times, so all the way to is directly proportional to is equals some number times the square root of x I want to create one equation that has the same meaning as the sentence, and I'm not going to get two equal signs in a problem that has one equation. So when I go to rewrite the part that and inversely proportional to y, I'm going to just say and equals some number divided by y's, but I'm not going to get a second equal sign. And maybe I shouldn't put another word equals in there. That it looks like I should need two equal signs. So I'll say it equals some number times the square root of x, and I'm going to skip the equal part of this, and some number divided by y. So this is a little clunky here because I have two different operations in the same problem, and I'm supposed to be able to accomplish this sentence with only one k and only one equal sign. So for each of the problems, I don't expect to use more than one k nor more than one equal sign. So I need to accomplish this with 1k and one equal sign. So the W part is going to be just fine. When I go to write my equation, I'm going to write the letter W. For the equals, I'm going to write an equal sign. For the sum number times the square root of x, that's going to go, some number is k, times the square root of x is going to be followed by a square root of x. That's the beginning part, that W is directly proportional to the square root of x. I have more to add in, and what I need to add in is a fraction with a k in the numerator, because for the sum number divided by y, the sum number divided by y would be a fraction with a k in the numerator, because inversely always gives me a fraction with a k in the numerator. And what's going to go in the denominator of that fraction is a y. And that y doesn't have any words preceding it that indicate it needs an exponent or a radical sign. So in the denominator of that fraction, I'm just going to get a lone letter y. And I'm doing it with the k that I've already shown. So I can see both pieces, and I actually have the answer written here. The sum number divided by y represents the k divided by y, and the sum number times the square root of x is this k times the square root of x. Let me squeeze on here your problem. Let me rewrite problem 5. So this is the answer to problem 6. For your problem, I would think of your number 5 as q equals, so I'm just rewriting it without this word, some number times the square of x and then for inversely proportional, divided by, and some number divided by, and then the cube of y. So your problem 5 has both the same basic word set I had. So as I go to write an equation, I'm going to write the letter q, then an equal sign, and my sum number is going to be k, and then the first part of the sum number, it needs to be times the square of x, because there's not a root after the word square. I don't get a radical symbol, I get an exponent. So times the square of x is going to be times x squared, and then some number divided by the cube of y. For divided by, we're forming a fraction, and in the denominator of that fraction needs to be the cube of y. Again, I don't see the word root, so I don't see a radical symbol. I'm going to get an exponent, and the exponent's going to be a 3. So this would be the transformation of problem 5 into a set of symbols, or into an equation. And I have both things. In the numerator, I have the varies directly. It's some number times the square of y. And this fraction, if I ignore the x squared, I see the sum number divided by the cube of y. So that would be how we handle a problem that has two different kinds of variations together. Problems 7 and 8 have the last kind of operation that we have to worry about, the varies jointly as. And varies jointly as, I think, multiplication. The reason jointly and directly are separated is because indirectly, the multiplication, you only have one letter after the k, and in jointly, it's a multiplication problem, and there's going to be, instead of one letter after the k, there's going to be two letters after the k. So the reason there's different words between that mean multiplication, both directly and jointly mean multiplication, in the word jointly, there's going to be two letters after the k. So when I go to rewrite this problem, I'm going to replace the word varies and jointly as equals some number times, and then I'm going to write my equation. So for number 8, I can think of this as b equals some number times that's all that's dumped out for those words, and then x and the square root of y. So the first letter I see is b, I'm going to write it. I see an equal sign, I'm going to write that equal sign. For some number, I'm going to write a k. I don't need the time sign because I'm going to put a letter after the time sign. In fact, no, it's part. Just had a glitch, so for the sum number, I put in a k. For the times, I'm going to leave it just the letters written next to each other to indicate the times. Then the next letter I see is x. There aren't any words preceding x, like square, cube, square root, or cube root. So the x is just going to be a single x to the first power. And then, and the square root of y, the y is going to be under a square root symbol. And that would be perfect for my answer to 8. Here, the word and doesn't mean add, it just means another letter being multiplied. All right, so that's the beginning of section 2.4, and every problem in section 2.4 is going to have this skill that we need to be able to take a sentence with the words inversely, jointly, or directly and transform it into an equation. Heck, I guess there's more problems to this. Well, let me get these. So 9, 10, 11, 12, 13, 14 also want me to translate words into a sentence, but they weren't preceded by the instructions. When I wrote the instructions, it probably should have said for problems 1 through 14, write a variation model, use k as the constant of variation. Because 9 and 10 don't have new instructions, and let me see if I can do that for them. So each of the problems up through 14, not just up through 8, I need to take the words and translate them into equations. So for problem 10, I read through the problem, I look for the key word. The key words is varies directly as. So if I wanted to rewrite problem 10, I can say the monthly payment P on a mortgage. There's a lot of words right there, and all those words are going to simplify down to just one symbol, and then equals some number times and then the amount borrowed B. When I rewrote this problem with the varies words cleaned up, I kind of broke it into 3 pieces because each one of those pieces shows up as just one symbol in my problem. So I need to translate a bunch of words into just 3 symbols, essentially, maybe 4 symbols. So the first part of this problem, the monthly payment P on a mortgage, that's going to just translate to the letter P. So this whole fragment of a sentence, the monthly payment P on a mortgage, turns into the letter P. So this P stands for the monthly payment. And then the varies directly as, I change to equal some number times. That's going to be equals and then K. So now I'm done with that set of words, which is equivalent to this set of words. And then the last part of it, the amount borrowed B, the letter that's going to follow the K is a B, because that's the only letter I see in the problem after the words varies directly as. I have to decide if that letter needs an exponent or needs to be under a radical sign. And as I look here, I don't see the word cube, cube root, square, or square root. When I don't see any of those 4 words, that indicates the B is just going to be a plain B, and it's going to absolutely follow the K because this is directly and it's a times problem. So this is the answer to number 10. So you should be able to give 9 a go. You're going to break the problem into this bit, and then that bit, and then that. So you're going to get 3 different pieces. From the first few words, you're just going to gather out the word D. For the is directly proportioned to, you're going to get an E and a K. And for the last part, for the square of the time that it falls, you're going to get the letter T, and preceding the letter T is a word that implies an exponent of 2. So I kind of snuck in an answer to your problem 9, just in case you weren't sure how to go about doing it. All right, so 11 and 12. Let me do 12. 12 says the demand for candy at a movie theater. So all of this right here is just the first bit that gives me the one letter for the problem. So there's a lot of words that condense down to a single letter. And then I'm going to use the words is inversely related to, and those I'm going to change to equals some number divided by. And then the last words I'm going to focus on the price P. So for each of the problems in this grouping, I have to get like kind of 3 chunks of words. My first words, the demand D for candy in a movie theater, that's going to condense down to just the letter D. All these words, the letter D is going to mean how much candy is being sold at a movie theater. And then the inversely related to, I get an equal sign, and I know inversely is a fraction with a k in the numerator. So the equal sum number divided by, I use k for the sum number, I use a fraction symbol for the divided by, and then lastly, this what's going to go in the denominator is the letter P for the price. And in this little segment of words here, I don't see the words square, square root, cube, or cube root, so the P is just going to be a single linear P. And my answer to number 12, the equation that has the same meaning as that sentence, is D for the amount of candy sold equals K divided by P, the price of that candy. All right, so give 11 a go. And we can move on and do 13 and 14, and then we'll get to the next kind of problem. So, wow. So to start 14, the first long bunch of words in 14, the diameter D of the largest particle that could be moved by a stream. So those words are going to condense down to a single letter. And then I'm going to replace the words varies directly as is equal some number times and then the square of the velocity of the stream. This square is more part of the end. So we're going to get big chunks of words that condense down to really minimal symbols. So the first bit of this, the diameter D of the largest particle that could be moved by the stream, all those words condense to the letter D. So when I see the letter D here, that tells me the diameter of the largest particle that could be moved by a specific stream. Then the varies directly as is going to be equals some number times, so I write an equal sign and then a k. I only get a fraction if I see the word inversely. If I see the word directly or jointly, I'm straight multiplication. Directly, there's one letter after the k. Jointly, there's 2 letters after the k. So I'm done with that sentence. Moving on to the last sentence, I need the square of the velocity v of the stream. And so the letter I need to use is v, and there's a word that implies that that v needs an exponent, and it needs an exponent of 2. So preceding the symbol for velocity, there's a key word in there that tells me I need more than just the letter v. So the answer to number 14 is going to be d equals kv squared. That represents those words into a really concise equation. So hopefully you can give 13 a go. I'll maybe do 13 for you. 13 is a little bit harder because it has 2 words. And let me do it without rewriting because I don't have so much words. So the beginning of problem 13, the volume V of an enclosed gas, that right there is just going to turn to the letter V. The next words I see are varies directly as, and varies directly as I get an equal sign followed by a k, and directly as a multiplication. So after that k, I need to multiply something. And what I need to multiply it by is the temperature T, and before the word temperature, I don't see square, square root, cube, or cube root, so the T is just going to be multiplied by the K, and you're not going to get an exponent with the T. And then it would be nice if I was done, but we have extra words tacked on, and the extra words are inversely as the pressure P. Inversely, I need a fraction with a k in the numerator, so I'm going to put a fraction under that kt. There's a fraction with a k in the numerator. It actually has a k and a t in the numerator. And what goes in the denominator is something that represents the pressure P. And preceding the word pressure, I don't see square, square root, cube, or cube root, so it's just going to be a single P that goes in the denominator of that fraction. And there's your answer to number 13. So I did a few more problems than I maybe wanted to, but I didn't know if these problems were similar enough for you to make that connection. The next problems between 15 and 20 are the first problems that we see numbers in the problems, and the instructions become different. The instructions say find the constant of variation, k. So for each one of these problems, I have to do two parts, and the instructions are vague. They wouldn't know that they mean to do two parts, but you will have to do two parts. And again, if you read mathematics frequently, you'd understand that that implies two parts. So for each of the problems between numbers 15 and 20, first I'm going to create an equation with a k, that models the problem. And then second, I'm going to substitute the given numbers into the problem and solve for k. The way the wording of the instructions is written, find the constant of variation k, the only answer that I need to write down is what the k is. I need to create the equation to be able to understand how to find k, but I don't need to write this in my answer. So this right here should not be included in the answer, even though I need it to get the answer. The answer is just whatever k happens to equal to for this problem. That's not included in the answer. So let me go through and show you how I would do 16. First part of 16, I would take up to here and make that into a equation. So m varies directly as the square root of y. The first letter I see is m, so I'm going to write the word m. And then you always get an equal sign after that first letter, and you always get a k after the equal sign. If I see the word inversely after that k, or under that k, I'm going to write a fraction. If I don't see inversely, I don't get a fraction. I get straight multiplication. If it's directly, I get one letter multiplied after the k. If it's jointly, I get two letters multiplied after the k. This is a directly problem, so I'm going to get one letter after the k, and that letter is going to be a y, but the y is going to be under a square root symbol. So that's my step one for problem 16. I created an equation with a k without actually rewriting the equation into bunches of words. The next thing I'm going to do is use that m is 12 when y is 16. So I'm going to put in 12 for m and 16 for y. And that's going to give me 12 equals to k times the square root of 16, which is k times 4, which I'm going to write as 4k. And now I'm going to divide both sides by 4. On the left side, 12 divided by 4 is 3. On the right side, I canceled out the 4's, and I'm left with the k. The answer to problem 16 is just going to be k equal to 3. I'm not going to have any equation in my answer, although it wouldn't be wrong to put it, it's just not necessary to put it. So again, when you do problem 15, the first thing you're going to do is get up to there, create an equation with a k. Once you have that equation with a k, you're going to plug 45 in for y and 3 in for x. You're going to solve for k. Your answer is just going to be what k equals to. All right, 17 and 18. For 17 and 18, I'm going to find an equation with a k. And when I go to do problem 17, I'm going to go up to here. The first letter I see is a z. I'm going to write a z followed by an equal sign. The word that I see after the z is inversely. Inversely is a fraction with a k in the numerator, so I'm going to put a fraction with a k in the numerator. And then in the denominator, the letter I'm going to get is the x, and there aren't any words preceding the x like square, square root, cube, or cube root, so the x isn't going to be under a radical, nor is it going to have an exponent. So that's going to be my equation. And now the algebra. When one of the problems in inversely, I usually solve for k by cross multiplying. So for inversely problems, I usually solve for k by cross multiplying. You don't have to solve by cross multiplying, but that's what I like to do. So I've done the first step. I created my equation with a k. Now I'm going to use the numbers. And the numbers I'm going to use are 20 for x and 4 for z. So I'm going to write 4 equals k over 20. And if I'm going to solve by cross multiplying, I want both sides to be a fraction. The left side's not a fraction, but I can make it into a fraction by writing it over 1. So the problem 4 equal k over 20 has the same solution as 4 over 1 equals k over 20, because 4 over 1 is just 4. I'm going to cross multiply in both directions. When I cross multiply down, I'm going to get 1 times k. When I cross multiply up, I get 1 times k. When I cross multiply down, I get 4 times 20. My answer for number 18, on the left side, 1 times k leaves me with the k. And on the right side, 4 times 20 gives me an 80. Your 17 should work real similarly because you have the word varies inversely. Varies inversely, you know you get a fraction with a k in the numerator. Inversely is fraction with k in the numerator. Jointly and directly is multiplication. Directly is multiplication with 1 letter after the k. Jointly is multiplication with 2 letters after the k. 19 and 20 are varies jointly, so let me come up with an equation. When I go to do problem 20, that bit of the problem I'm going to create an equation with a k. The first letter I see is n. I'm going to write an n. I'm going to follow it by an equal sign. I don't see the word inversely, so I don't get a fraction. I see jointly. I always write a k after the equal sign. No fractions because there's not inversely. And since it's jointly, I need 2 letters after the k. And the 2 letters I need are x and y. The y doesn't get an exponent or it doesn't go under a radical symbol because there aren't the words square, square root, cube, or cube root preceding the y. The x is going to get an exponent of 2 because just before the word x I see square without the word root. So that's the equation for number 20. Now I'm going to plug 3 in for x, 2 in for y, and 54 in for n. So the n's going to be 54. The k is going to be k. The y is going to be 2. I'm going to put it in a parentheses because there's so many terms being multiplied. And the x is going to be a 3. I'm also going to put it in a parentheses. I have to watch my orders of operations. I have to do the exponent first. So on this right-hand side, I have k times 2 times 9. That comes out to 18k. So I'm going to rewrite this as 54 equals 18k. And now I'm going to divide both sides by 18. 54 divided by 18 is 3. And on the right-hand side, I force the 18s to cancel. So my answer to number 20 is going to be k equal to 3. I'm debating on whether to break this into a part 2 for the video, but I don't think I will. We have about 7 problems left each. It's going to be about 15 minutes, which means the video is going to turn into about an hour and 10-minute video, and I think that's right on the edge of being ridiculously long, but I'm going to live with it here. Alright, so next group of problems, 21 through 34, the instructions are really small. They just say solve, and in this group of problems, when the problems have the instructions solve, they're 3-step problems. The instructions get shorter, but the algebra gets more involved. So for the solve problems in numbers 21 through 34, first I need to create an equation with a k, and then second I'm going to use the first set of numbers to solve for k, and I wrote use the first set of numbers to get a value for k, and third use the last sentence, the last set of numbers, or the second set of numbers, to get an answer for the problem. So again, if you've never done these before, just by glancing at the problem, you might not know exactly what to do, and that's completely fine. But when we get to a test over this stuff, you should know what to do because you've done enough practice. So first step in problem 22, I'm going to create an equation that has a k. I'm going to use the first sentence to do that. And in my first sentence, the first letter I see is the letter z. I'm going to write a z followed by an equal sign. The key word is directly, so I don't get a fraction. After all these problems, I need a k. If I see the word inversely, I need a fraction. Directly or jointly, I don't need a fraction. So this is a directly, I don't need a fraction. After the words directly, I see the square of x, and that gives me an x with an exponent of 2 after the k. Done with the first sentence, I'm going to move on to the second sentence, and the second sentence will take me to the second step. It says z equals 54 when x equal to 3. So for the z, I'm going to plug the number 54 in. And then for x, I'm going to plug the number 3 in. This simplifies to 54 equals to 9k. And I'm going to divide by 9. 54 divided by 9 is 6. That gives me 6 equal to k. So first I created an equation with a k. Second, I used the first set of numbers to get a value for k. Lastly, use the last set of numbers, actually the last number, and the value of k to get an answer. So find z. In the last step in this equation, I'm trying to find z. I'm not going to plug a number in for z. When x equals negative 2, well, k has to equal 6. So I'm going to plug in 6 for k, and I'm going to plug in negative 2 for x. And this is going to give me my answer. Orders of operations want me to do exponents first. Negative 2 squared is negative 2 times negative 2, which is positive 4. And then 6 times 4 is 24. The whole answer to problem number 22 just needs to be the number z equal to 24. I don't have to write the equation that I generated from the first step. I don't have to include the value of k that I found on the second step, but I could. It's just not necessary. So your problem 21 should work pretty similarly. I'll move on to do 24 and give you a shot to do 23. So for 24, first, create an equation with a k. Then, second, use the first group of numbers to solve for k. Third, use the last numbers, or the numbers in the last sentence, to answer the question. So for each of the rest of the problems in this section, regardless of how wordy they get, I'm going to do exactly that. So first sentence, I'm going to create an equation with a k. The first letter I see as m, I'm going to write an m followed by an equal sign. The key word is inversely, and inversely is a fraction with a k in the numerator. So I set up for my inversely. And then in the denominator is something that represents the square root of n. That means n has to be under a square root symbol. Inversely's I like to solve by cross multiplying. Now I'm moving on to the second sentence. My second sentence says m is 15 when n is 9. So in for the m, I'm going to plug the number 15. In for the n, I'm going to plug the number 9. I like to set these up to solve by cross multiplying. So I need to write the 15 as a fraction. I'm going to write it as 15 over 1. And on the right hand side, I'm going to replace the square root of 9 with 3 because that's what it's equal to. I'm going to cross multiply up and cross multiply down. When I cross multiply up, I get 1 times k. When I cross multiply down, I get 15 times 3. And that gives me k equal to 45. So first I create it with my equation with a k. I use the first group of numbers that's in the second sentence to get a value for k. And now I'm going to use the numbers in the last sentence, or the number in the last sentence, to solve for what needs to be solved. I need to find m, so I'm going to leave the m in the equation as an m. In my equation for k, I'm going to plug 45 because I figured out for this problem k is equal to 45. And then for n, I'm going to put the number 16, and that n has to be under a radical sign because in the problem n's written under a radical. My answer to problem 24 is going to be a fraction because this fraction's not going to reduce. My answer is going to be m equals 45 in the numerator, and the square root of 16 I'm going to write as 4. And that's not a reducible fraction, so I'd leave my answer right there rather than doing a decimal version of that. Alright, so you should be able to do 23. Getting ready for that last hiccup. So 26. First, create an equation with a k. The equation with the k is going to be gotten by taking those words and making them into an equation. The letter b followed by an equal sign. Had a hiccup there. The letter b comes first, so I'm going to write the letter b followed by an equal sign. The key word is jointly, so I don't need a fraction. I only need fraction if I see inversely. If I see directly or jointly, I need straight multiplication, so I'm going to write the letter k and not a fraction. Jointly implies there's going to be 2 letters after the k, and my 2 letters are going to be the letter a and the letter c. Before the word letter A, I don't see square, square root, cube, or cube root, so the A isn't going to have an exponent, nor is it going to be under a radical. Preceding the word for C, I see the square root, so C needs to be under a radical symbol. That's done with the first sentence. I'll move on to the second sentence. In the second sentence, I'm going to plug 60 in for B. I'm going to leave k alone. I'm going to plug 5 in for a and put it in a parentheses just because I've got so many things stringing together that the parentheses will help me show that multiplication. And I'm going to put the c under a radical as a 9. The 9 doesn't really need to be in a parentheses or radical. It's kind of separating the 5 and the 9. Now I'm going to work on figuring out what k equals to. The c, the square root of 9, becomes 3, and once I took the square root, I put it into a parentheses because I lost the radical, which means I kind of need the parentheses now. Simplifying that right-hand side, we get 16. 60 equals 50k. And now I'm going to divide both sides by 15. And that's going to give me 4 equal to k. So I did my first step, my second step, done with the first two sentences, move on to the third sentence. The third sentence says find b, which means I'm going to leave that b alone. I'm going to plug 4 in for k because that's what the algebra gave me. And in the last sentence, I'm supposed to plug also 4 in for a. So for that a, I'm going to plug in 4. And I'm supposed to plug in 16 for c. So for that c, I'm going to plug in 16. And I'm going to go b equals 4 times 4. And the square root of 16 is also 4. Once I take the 16 out of the square root and turn it into a 4, I threw it into a parentheses. And my answer for number 26 is what those multiply out to be. And 4 times 4 times 4 is 64. So I'm going to say b equals 64. So that should motivate you to do 25. Now we have the long problems. And we have 1, 2, 3, 4 long problems. The long problems aren't really any different. They're just longer, so they look more imposing, but they're not. So, step 1, use the first sentence to create an equation with a k. As I read through the first sentence, suppose the demand D for candy at a movie theater is inversely related to the price. Inversely means I need a fraction with a k in the numerator. Preceding the word inversely, I need to write something for the demand for candy, and I'm told to use the letter D for that. So for the first sentence, I'm going to write a D, and equals varies inversely as a fraction with a k in the numerator. So this D represents the demand for candy. The inversely is the fraction with a k in the numerator, and it's inversely related to the price P. The letter I need in the denominator of that fraction is a P, and I don't see any words that directly precede the P, like square, square root, cube, or cube root. So that P is just going to be a lone P without any radical symbols or exponents. Done with the first sentence, move on to the second sentence. The second sentence is going to give me values for the numbers. It says when candy is $4 per bag, we sell 150 bags of candy. The $4 is supposed to be the price. I'm going to put a 4 in for the P. The 150 bags is supposed to be the demand. I'm going to plug 150 in for D. So I'm going to go 150 equals K. And I'm not going to put the decimals with the 4 because it's going to make it hard for me to solve. And usually varies inversely I solve by cross multiplying. So I'm going to make the 150 side into a fraction by putting it over 1. Then I'm going to cross multiply up and cross multiply down. I'm going to get 1 times K equals 150 times 4. That's going to give me K equal to 600. Done with the second sentence, go to the third sentence. Determine the number of bags of candy that will be sold when the price is raised to $5 per bag. I need to use this formula. I need to plug that number into the formula, and because that is $5, it doesn't go in for the D. That's a price. It goes in for the P. So for the last sentence, I'm going to leave the D alone. In for K, I'm going to put 600. In for P, I'm going to put 5. And it's going to give me an answer for D. That's the number of bags of candy that we're going to sell. And let me do that on my calculator. Do 600. I think it's 120 divided by 5. I get 120. So because this is a more wordy problem, I should probably have more words to my answer. And this 120 represents the number of bags of candy sold. So let me just say 120 bags of candy will be sold when the price is $5 per bag. So this would be a nice answer for 28. So you should do something very similar for 27. It's exactly the same words, just the numbers are different. Your numbers are a little bit harder, so you might need a calculator. Generally, when I do word problems on the test, they go just like this. I will give you a word problem that's identical to one of the word problems in the homework, but I change the numbers. If you laid problem 27 and 28 on top of each other, you'll find that they're written exactly the same, except the three numbers in my problem are different than the three numbers in your problem. If on the test I was going to give a movie theater demand question, it would be exactly this with different numbers, so I don't get crazy when I do word problems long word problems on a test. All right, so 29 and 30. Again, if I laid problem 29 and 30 on top of each other, they would fit exactly together. Except the numbers might be different. If I start to look at your problem, its numbers and the numbers in my problem, a lot of the numbers are the same. The only numbers that are different between problems 29 and 30 are these last few numbers, so most of our work is going to be the same. All the words are the same, just the numbers are different. I need to do this in 3 steps. So my first step in problem 30 is to create an equation that models the first sentence. It says, a gas law states the volume of an enclosed gas varies directly as the temperature and inversely as the pressure. I don't see any words like square, square root, cubed, or cube root, so I'm not going to have any exponents or radical symbols in this problem. The first letter I run across is the letter V, and that's before any of the inversely or directly words, so I'm going to have a V followed by an equal sign, and that V represents the volume of an enclosed gas. And then, boom, I see varies directly. I know I need a K, and after that K, I'm going to multiply by something. And what I'm going to multiply by is the temperature T, which is just the letter T. I don't see before the word temperature square, square root, cubed, or cube root, so I'm not getting an exponent or a radical symbol. And then after the T, it says and inversely, so I need a fraction. That K is going to be in the numerator of the fraction. And in the denominator is the pressure P. That P is going to go in the denominator, so the KT in the numerator shows me the varies directly. This K over P shows me the varies inversely. Done with the first sentence, I move on to the second sentence. And in the second sentence, I'm given some numbers. I'm going to take those numbers and plug them into the problem. That'll help me solve for K. I'm given 3 numbers because there's 4 letters and one of them's a K. And if I put those 3 numbers in, I'll be able to figure out what K is. The first number says the pressure of a gas is 0.75 kilograms. I'm going to plug 0.75 in for P. And I'm not going to show any units here, and I'll talk about the units when we get done with this problem. And but not include them in the computation because it makes the computation too messy. So I put the first number 0.75 in for P because it stands for pressure. And then the next number says, and when temperature is 294, well, temperature in my problem was the T, so I'm going to put 294 in for T. I shouldn't have written the V because I'm going to put a number in for the V. And the third number I see is volume is 8,000 cubic centimeters. That should have went in for the V. And the K is the unknown. So what I should have written is 8,000 equals K times 294 over 0.75. And I'm going to change that to 8,000 over 1 equals, and then K times 294 looks odd. How about 294K over 0.75? So it's inversely in there, so I'm going to solve by cross multiplying. I'm going to cross multiply up and cross multiply down. When I cross multiply up, I get 1 times 294K. When I cross multiply down, I get 8,000 times 0.75. I probably should yank out another sheet of paper for this. So the left side is easy. 1 times 294K is just 294K. The right side's not so easy. What's it come out to, like 6,000? Do 8,000 times 0.75, and I get 6,000. Now I'm going to figure out what K is by dividing both sides by 294. My instructions say round K to 2 decimals, so I'll go ahead and round K to 2 decimals. and not leave it as a fraction. So I'm going to get k equals to 6,000 divided by 294. And that rounds to 20. The number in the third decimal place is an 8, so I'm going to round that 0 up to a 1. So for my k, I'm going to get 20.41. When you go to do your problem 29, because up until the last sentence, the words are exactly the same, when you go to do your problem 29, all this part's going to be the same. To finish up my problem, I go to the last sentence. I have this equation that I need to work with. I have the number k that I need to work with. And it says find the volume, so I'm going to try to solve for v. So in the last sentence, I'm going to leave the v alone. I'm going to write my equal sign. In for the k, I'm going to put 20.41. In for the p, because it says when the pressure is 2 kilograms per square centimeter, I'm going to put a 2 in for the p. And the temperature is 400 degrees. I guess that means Kelvin. And I'm going to put a 400 in for the temperature. I'm not putting any units in. I'm trying to find the volume. And as I read my problem, the volume is in cubic centimeters. When I go to write my answer, I'm going to say the volume is something in cubic centimeters. And it's going to be whatever that number comes out to be. To get that number, I have to go 20.41 times 400 divided by 2. I get 4,082. And so my answer to number 30 the volume is going to be that number, 4,082. And the units for the volume are given at where the units are. So the volume is in cubic centimeters. So all right, so you should be able to do 29. It has exactly the same wording as problem 30, so your work should be exactly the same, except when you get to the last sentence, the numbers are different. All right, so 2 more problems each. And again, if you look at the problems, my problems and your problems are exactly the same. The only difference between my problem and your problem is the numbers. And that's going to be for any test question. Any test question could only be one of the problems in this grouping of problems, except with different numbers. So first sentence in problem 32, I'm going to use it to get an equation with a k. As I read through this problem, the distance d a ball rolls down an inclined plane is directly proportional to the square of the time that it rolls. The first letter that I'm going to get in the problem is the D. That stands for the distance a ball rolls. And then for the is directly proportional to, I need an equal sign with a K. It's not inversely, so I don't need a fraction. Directly is multiplication with one letter after the K. Inversely is a fraction with a K in the numerator. Jointly is multiplication with 2 letters after the K. This is directly, so it's multiplication with 1 letter after the K. The letter I needs to represent the square of the time, and the word square gives an exponent of 2. So that's the equation that I would get from my first sentence, d equals kt squared. Now I'm going to use the numbers in the second sentence. The numbers in my second sentence are 1 second and 8 feet. 8 is a distance, so I'm going to put 8 in for the d. 1 is a time, so I'm going to put 1 in for a t. So this is going to give me 8 equals k times 1 squared. This is going to give me 8 equals 1 times k, which is going to give me 8 equal to k. So first sentence, an equation with a k. Second sentence, get a number for k. Last sentence, answer the question. And I'm going to answer the question, how far will it roll in 6 seconds, by using d for distance, 8 for k, and 6 for t. I'm going to do this all on my calculator. That's going to be 8 times 36, which is 288, because this is 8 times 36. My answer is going to be distance equals 288. Should probably put units on that. So let's see where the distance is. Well, the distance in this problem was given in feet. So my answer should be, it's going to roll. How far will it roll? My answer is going to be 288 feet because the distances in this problem are given in feet. So for number 32, my answer is going to be it will roll 288 feet. If I just wrote 288 feet, it would be nice, but it would be better if I said the ball will roll 288 feet. If this was a test question, you just wrote 288 feet, I'd completely be okay with that. So you should be able to give 31 a good go. It's the same problem with just one number that's different. The only thing that's going to be different on your work for 31 is this very last grouping. The initial equation and the solving for k has exactly the same number, so you're going to get the same work as mine. All right, last two problems. Well, first sentence, I need to create an equation with a k. The diameter d of the largest particle that can be moved by a stream varies directly as the square of the velocity v of the stream. The first letter I see is d. I'm going to write it to the left of an equal sign. And that represents the diameter of the largest particle that could be moved by a stream. Then I see it varies directly, so I need a k without any division. And then the square of the velocity v, that velocity needs an exponent of 2. So that junky equation converts to d equals kv squared. Now I'm going to plug some numbers in. The first number I see is a quarter, and that is the velocity. So that a quarter is going to go in for the v. And then can move coarse sand particles about 0.002 inches in diameter. That's a d. So the two numbers I see in the second sentence, the 1/4 goes in for v, the 0.02 goes in for d. So I'm going to go 0.02 equals k times 1/4 squared. 1/4 squared equals 1 squared over 4 squared, and that's 1 over 16. So I can rewrite this as 0.02 equals 1/16 k. Because I'm going to use my calculator, I'm not even going to get fancy. I'm just going to divide both sides by 1/16 to solve for k. On the right side, when I do my calculator, I'm going to go 0.02 divided by 1/16. To be safe, I'm going to put the 1/16 in a parentheses. It might not have to be in a parentheses. So I'm going to go 0.02 divided by parentheses 1/16. That gives me 0.32. And on the right-hand side, I force the 1/16 to cancel, and I have the k. So first sentence, which was the nasty part of this, I used to get an equation for k. Second sentence, I solved for k. Third sentence, how large of a particle can be moved? And how large of a particle can a stream move that has a velocity of 5 miles per hour? 5 miles per hour. D is what I'm solving for. D is the diameter of the largest particle that could be moved, so I'm finding its diameter. I'm using 0.32 for k, and I'm putting 5 in for the v. So when I go to do this problem, I'm going to find the diameter, and I guess it's the diameter in inches of the largest particle that can be moved by going 0.32 times 5 squared, and that's 8. And I have to understand what the units are for that. That's going to be 8 inches. So a stream moving 5 miles per hour can move an 8-inch diameter particle. So for an answer, I could just say how large of a particle? 8 inches. Or I can say a stream moving 5 miles per hour can move a particle with an 8-inch diameter. So this would be completely okay for a test. The sentence, it shows that you understand what you've computed better, but it's not a deal breaker if you don't give it to me. There's the work again in case you need to see it. And there's your problem 33. It's exactly the same problem with different numbers. You'll notice each of the really long word problems was just my word problem with different numbers. That would absolutely have to be the case on the test. On a test, I won't give you word problems that are exactly like something that we solved. You're guaranteed not to be tricked up on word problems. All right, that has to be enough for this section. Sorry for the length.